everybody, my name is Ariel.
And my name is Alice.
From Bach Studio. We're here today at the Princeton University to meet with Professor Thomas Gregor, who will talk to us more about biophysics.
We're so excited. Are you ready? Let's go! Hello, Professor Gregor, and thank you for making the time to meet with us today.
Hi guys, I'm honored that I'm one of your interviewees.
What is physics, and what is the difference between physics and biophysics?
Physics, as you might have heard, is try to understand how the world works, how things around us move, and how, how a ball drops on the floor. And biophysics is like how living things work, how tiny little cells move in a body, for instance, or how your heart works. And so biophysics is very similar to physics. When physics tries to understand the world, biophysics tries to understand the living world, but using the same kind of rules than we use in physics. And one of the peculiarities in physics in general is that it tries to understand the world around us, but using mathematics as a language.
So how can your research help make the world a better place, and how is your research relevant to everyday people?
Yeah, that's also a very good question that we always, as scientists, should be thinking about. My science is fundamental. I do fundamental science, and fundamental science tries to understand the really difficult and complicated questions. And for fundamental science, it's not immediately clear how we can use it later on. But nevertheless, it's very important that we ask questions that are fundamental, because eventually people will find something that will be able to use the findings that we make by doing fundamental research. For example, when people understood first electricity, we had no idea that one day we would have light bulbs and computers, right? But now this is everywhere in our everyday life. And so this is how it works with fundamental research. The difference, the gap between when we understood electricity and when the first light bulb or even the first computer came up, there was a very, very long time span in between. And so biophysics hopes to understand living creatures as well as we understand the inanimate world with real physics. And so one day we hope to be able to, help solve diseases or even grow organs from scratch or something like this,
What is the biggest mystery in physics that you'd like to solve, and why?
I'm working on biophysics, and so one of the big problems we have currently, as you might have heard, of climate change, that our planet, we reach the boundaries of what our planet can actually sustain in terms of population and in terms of energy consumption, etc. And you might have heard also about the fact that in not too far of a future, maybe even in your lifetime, we will have very little oil left. And the only really sustainable way to have technologies or to have anything on Earth go beyond our fossil exploitation is using sun energy, because sun is the only energy source that's for free and that will be for another 5 billion years, right? And so one of the ideas would be to make things like an iPhone from living cells. It's because if we could have cells, these cells will be created somehow by sun energy. And so it will be sustainable, it will be regeneratable, okay? And so the idea would be to come up with ways to make technology possible just from live-based entities like cells or organs or something like that. And so that's, in a way, one of the biggest mystery for me. How can we turn our cell phones, if you want, into something that is living and hence doesn't need fossil fuels in order to be created.
So what is the most remarkable discovery you've made in your experiments?
So as a physicist, I try to also understand how living systems grow and develop into bigger animals. And I'm doing this with fruit flies and since recently also with larger mammals. And what we do is we build microscopes and cameras with which we can follow the building blocks, cells or molecules inside of these flies or inside of these developing organisms. Okay? And what we have been able to do, we have been able to create special cameras, if you want, with which we can follow genes and how they give the instructions for cells to eventually know where they are and what they are in the body. So in a way, the genes lay out a blueprint for cells to know, oh, I'm going to be a head cell or I'm going to be a tail cell. And so that is kind of where my research comes in and where we figured out how is this blueprint set up at the molecular level and how it then helps the organism to determine, well, I should be a wing or a leg or a head. Okay.
How did you develop interest in studying physics, and what are some things you would recommend to kids like us to do if we want to become a good physicist?
I was always curious to understand how the world around us works. And I think if you ask yourself questions and never stop asking yourself questions and are curious and trying to figure out, well, what's behind it? Why is the sky blue? There must be a reason for why the sky is blue, right? Or why is our heart beating? What makes us living creatures survive or continue to live? Well, if you keep on asking yourself those kind of questions, you'll be able to be curious enough to eventually become a scientist or have this drive to just understand, be curious about what's going on in the world. Also at home, try to experiment yourself and play with tools that you build something. You probably have Lego at home, and that's kind of certain things that I did as well. It's also interesting or important if you like math. Even if you don't like math, don't be afraid of it. It's like a puzzle, if you can see it as a puzzle. And if you just train yourself enough, you will be able to solve those kind of puzzles, and math can be one of such puzzles, because eventually physics will be described by math. And so it's good if you like this very early on.
Thank you, Professor Gregor.
Thank you, Professor Gregor.
Oh, you're welcome.
Well, there you have it. Physics can help us understand how things move or work, from tiny atoms to big substances, which is really interesting. So let's keep exploring. And for more, follow us on Bach Studio. See you next time. Bye!